Hey guys, welcome back to the lab in my garage. We are working at the bench again today, trying to get a little bit of chemistry in real life, not just looking at numbers on a page. We're going to go ahead and try and collect some data today and see if we can't figure out the solubility of salt. We've been talking about how reactions are reversible and that some things, when they go in reverse, they're going to be reforming their reactants. So we want to be able to look at our personal reaction today, which is the idea that salt is a very soluble substance, and the question that we're trying to determine is how soluble is it? How much can we actually get to dissolve? Now remember, when we're saying how efficient a reaction is, how far to the right, how much product is it going to make, we call that a K value. So specifically, because we're looking at solubility today, this will be KSP. KSP. So let's go ahead and take a look at the bench over here and see what we have available to us. All right, so what we have is a few instruments. We have our digital scale today. We're going to go ahead and turn the digital scale on, get that going for us. We have a couple of beakers, we have a graduated cylinder, and we have some table salts. Now, ideally, I would use something that was not iodized, right? So adding some iodine to there makes it not such a pure substance. But the goal here is to basically try and figure out how much salt is soluble, how soluble it is, and it's mostly salt. I mean, there's not a lot of iodine in here. If we were to switch over to the ingredients list here, you can see it's really a very, very small amount. It's coming in last on the ingredients list here. This is by and large mostly sodium, right? So we've got lots of sodium chloride there. And so we know that when we're trying to see how well something dissolves, you have to be working with a saturated solution. So what I've done to start is I've just taken a beaker. We've got that beaker and it is filled with some water. This amount of water probably is not the most important volume. It's going to actually change as we start adding to this, but we need to create a saturated solution. And so when we start to create a saturated solution, how can you tell if a solution is saturated or not? Right? We know that the way you can tell if a solution is saturated is if you add a little bit more, it just sinks to the bottom. So we have to basically put so much in here that no more will dissolve. So I'm going to start sprinkling some of this in, and I'm going to go nuts. I don't really care if I put a lot extra in. So I've added a ton to this. Right? And so we know that hopefully what I just did is I added way too much. So let's just see what we've got going on here. So we'll make sure we stir this in and try and get as much to dissolve as possible. But I can see we're starting to get a nice heavy layer that's sinking to the bottom. And we are going to go ahead and just let this dissolve and settle to the bottom. Okay, so we went ahead and we mixed the salt in. You saw we stirred it like crazy until we got to the point where it was as saturated as possible. And so now we have basically given this some time to sit, and we've allowed all of the solid that will not dissolve to sink to the bottom. And so what we see is this area up here is completely saturated. None of this water can hold any more dissolved ions. So all of the crystals sink to the bottom. So what we want to study is not this, right? We want to study this part right here. That's our saturated solution. So what we're going to do is we are going to get some of that solution and we're going to put it into the graduated cylinder here. So we're going to carefully take it just off of the top. So we're going to go ahead and do this a few times. Okay, we're getting there. All right. Let's see where we're at now. So we'll come over here and So we're going to go ahead and try and get our measurement on this. What would my measurement be for my volume? And we are going to take a couple of masses now. So we've got our digital scale and we have an empty beaker here. So we're going to go ahead and put that up on the scale. So our mass is 29.21. And now what we want to do is get our saturated solution into our beaker. So we're going to go ahead and pour that in there. Try and get most of those drops out. Okay. So we've transferred the solution to the beaker, and now what I'm going to do is heat this up. And what is going to happen when I heat this up? All right, we are back. We have taken that 10 milliliters and let it boil down. And so we go ahead and we take a look inside. We see all the salt that has shown up here. We got a little bit of splatter. Looks like it kind of crawled up to the side. So it's a possibility that we lost a bit. I threw it in the oven to dry it out, and so we were getting a little bit of burning here. That could be maybe some of the iodine from the iodized salt, or there was a little something in the beaker that started to burn as well. But we want to go ahead and mask the beaker again, so we're going to go ahead and put that up there, and we get 32.19. 32.19. So when we come over to the piece of paper, remember, couple little things that we want to write that 32.19 grams down. Remember that we're dealing with the equation of the salt dissolving, right? So we have NaCl is actually dissolving to give us Na plus and Cl minus. So we should have seen this before, right? That's a solid, or it was a solid. It turned to aqueous, And when we balance this, it's a 1:1:1 ratio. So what we're going to want to do now is write ourselves an equation, a KSP equation for this. We know that we have a mass up here, and this is a mass of NaCl plus the beaker. So what are we going to do with that number? Right, we know that we're probably going to have to try and find the grams of NaCl, and then what am I going to convert that number into? All right, good luck with that. Let's go ahead and solve for the value of KSP, the value of KSP for NaCl.